Hi, Math 3 students. Mrs. Robinson here to work practice benchmark chapter 4 with you. Let's get started. For questions 1 to 2, simplify the expression. So let me pull my pen out. Also we're going to do is do a little polynomial subtraction. Now you can just make sure when you do polynomial subtraction, you only subtract like terms. It's super important that you do that. So sometimes it's easier just to line them up underneath each other. The tricky thing about subtraction also is distributing that subtraction sign to every term. So I'm going to rewrite this under here with the subtraction sign. So it's going to be minus 10x squared. So I'm lining up the x squareds. This negative makes this a positive, so it's going to become plus 6y squared. I'm lining up the y squareds. And then the constant term. A negative and a negative is going to make this a positive 4. Now I'm going to go ahead and add down. Even though I am subtracting, I distributed that negative sign already. So it's 9x squareds minus 10x squareds, which makes negative 1x squareds. 6y squared plus 6y squared is positive 12y squared. And then 3 plus 4 is 7. And there I have it, negative y squared, or excuse me, negative x squared plus 12y squared plus 7. All right, let's look at number 2 is a multiplication problem. We're used to foiling when we have two binomials, but now you have a binomial and a trinomial. Degree 3 here on that trinomial. So I have to distribute each term to each term. So that means I'm going to have to multiply x times this, this, and this, and then 3 times this, this, and this. So let's go ahead and do the work. X times 3x cubed, well, 3x cubed times 1x is going to make 3x to the 4th. X times 3x will give me 3x squared. X times 4 will give me plus 4x. Now go on to the next term. 3 times 3x cubed will give me 9x cubed. 3 times 3x will give me 9x. And then 3 times 4 will give me 12. Now I'm going to stop and go back and combine any like terms I have. I only have 1 to the 4th power, so I'm going to write it down here. So my degree is to the 4th power when I have my polynomial. Remember, my degree is the highest degree of my polynomial. So I do have a 4th power here. Next I'm going to look at, so I'm going to cross that out. I only have 1 cube, so I'm going to do 9x cubes. And let's see, I only have 1 squared, so next I'm going to write 3x squared. Now I have 2x powers to the 1st power, so I'm going to combine these are like terms. So 4x and 9x makes 9, 10, 11, 12, 13 x's. And then I have 1 constant. And there I've simplified it, and that's it. Okay, classify the polynomial by the degree and term. Well, the terms, there are 3 terms, so it's a trinomial. And I'm classifying my polynomial by the largest degree, and here it is a cube. So I have a cubic trinomial here, and I'll write that down, and it's going to be ugly, but cubic trinomial. All right, let's look at this one. This one has 4 terms, so I'm going to call it a quartic. Because it's a polynomial of 4 terms. It's also a degree 4. It happens to be a polynomial of 4 terms and a degree 4. So the degree 4 would be the quartic. And then I would say it's a poly, P-O-L-Y. Let's see, I can spell that right. P-O-L-Y of 4 terms. Okay, quartic. And then it's got 4 terms. So we say binomial and trinomial. When you get to 4 terms, we say 4 terms, 5 terms, 6 terms, okay? All right, a monomial would be 1 term. Okay, consider the leading term of each polynomial function. What's the end behavior of the graph? Just so you guys can review, if you want to look on your page 241 to review this, go ahead and do that. I think page 241. The basic rule is you look at the first term of the highest degree of your polynomial, okay? If it's negative, if the constant is negative, and then this, so these are the things you're looking at, the degree and the constant. So let's look. Instead of starting with negative, Let's just review it like this. Okay. If the degree is even, so an even degree, and you have a positive constant, you're going to start up and end up. You might have some bumps, but you'll start up and end up. So it would be up, up. So think I'm even and I'm positive. Happy, happy, 2 thumbs up, okay? If you have an even and you're negative, okay, you're even here, but you're negative. Whenever you're even, you're going to either be up, up, or down, down, okay? Even means the same on both ones, either up, up, or down, down. If you're even and you're negative, you'll be like this, or maybe like this, some bumps. You'll be down, you'll start down, and you'll end down. So if you're even and you're negative, you're down, down, okay? Now, if you're odd, if you have an odd power and you're positive, you start low, but you end high. So you're odd, but you're positive. So you start down, but you end up. You may have some bumps along the way, but you're going to end up, okay? Now, if you're odd and you're negative, you're going to start, and my little face is in the way, but let me see if I can pull that out of the way. Okay, I moved it a little. If you're odd and you're negative, you're going to start up, but you're negative, so you end on the down note. Okay, you may have some bumps along the way, but you're going to end down. So you start up and you end down. All right, so let's look. We have an odd, or sorry, we have a negative and an odd. So we're odd negative. So we're going to start up and we're going to end down. All right, that's our end behavior. Now here our highest degree is 8. 8 is even, and our constant is positive. So a positive and even is a good situation. It's an up, up. And that's how I remember those. All right, guys. What's the degree of the polynomial that generates this data? Now, you could go ahead and graph this at Desmos or on a graphing calculator like this. And other data, and you know, like a line should look like a line, a quadratic should look like a U, a cubic would look something like this, and kind of look. But we know back from Algebra 1 or Math 1, if the difference between your x's is constant, and this is a mistake, this should be -1 right here. I'll fix that. -2, -1, 0, 1, 2. So the change is constant, the change is 1. Okay, I would look at the change in y here. And for linear, the change in y will be constant because I will have the change in y over the change in x, and that is my slope for a linear equation. Now, if the first change would be constant if it was linear. So first change for linear. Second change would be constant if it is a quadratic. Third change would be constant if it is a cubic. And then fourth change if it's a quartic, and so on. Okay, so we're looking at our changes here to see what we have. And I can already tell you the first change is not constant, so it's not going to be linear. I can tell by looking at it. But let's go ahead and go through this. To get from 15 to 6, I'm going to subtract, what is that? 15 to 6, subtract 9. To get from 6 to 1, I subtract 5. To get from 1 to 0, I subtract 1. To get from 0 to 3, let's see, I'm going to add 3. This is not constant, it's not linear. Let's go to our second change and see if I have a quadratic. Okay. To get from -9 to 5, I'm going to add 4. To get from -5 to -1, I add 4. To get from -1 to 3, I add 4. Yay, it's a second change, so this is going to be a quadratic. See, what's the degree? The degree will be 2 because it's a quadratic. And I'll fix that. That was a boo-boo. Okay, number 8 doesn't actually make us graph it. It just says describe the end behaviors and transformations of this graph and describe the end behavior. Oh, I repeated that, sorry. So here's this graph. It looks like it's a basic cubic graph. So if I had y equals to x cubed, okay. Then here, it looks like on the inside, I am shifting, remember, inside with the x, it's the opposite because your basic equation is something times x minus h, and that would be a cube because it's cubic, plus k. So the k is our up, down, and the h is our left, right. And this works for shifting almost any type of graph. And then this is our stretch, shrink. Okay, now this left, right is always opposite. So because this is a positive, that means when I do this, I add 2 to my basic graph. So this tells me I'm going to shift left 2 units. This is a straight up K, so this tells me up and down. I'm going to shift, then I'm going to shift down 3 units. And then this tells me stretch or shrink. This tells me I'm going to stretch by a factor of 3. So I'm going to stretch by 3, a factor of 3. Then I'm going to shift left 2, down 3. Describe the end behavior. Well, look here. If I were to multiply this out, I would have a constant here that's positive, okay? So I'm going to, when I go ahead and do the multiplication, because I have a positive a value, so I have a positive and I'm odd, okay? If I'm positive and odd, I'm going to start low and I'm going to end high. If we reviewed that, start low and end high. So the end behavior would be down, start down, and end up. And that's how I would describe that graph. Okay, what's the equation? Y equals x cubed. It has a horizontal translation, right 10, and a vertical translation, down 12. Now remember, we wrote this one out. Y equals a times x minus h squared, or cubed, it's cubed here, plus k. This is my left, right, my horizontal. This is my up, down. So this is my opposite one. So I'm going to go y equals 2. I want a horizontal translation to the right 10. So I'm going to actually go x minus 10. Cube that. And then a vertical. This is my vertical, up and down. And it's a vertical translation down 10. So I straight up go down 12. So I go minus 12. And there you have it. All right, I got to factor this guy. Write the polynomial in factored form. 6x cubed minus 60x squared plus 144x. Nice thing, I can see I can factor out a term here. I have an x in each term. Now I know 6 goes into 60. I could maybe pull that out. If 6 divided into 144, that would be nice. It does. It goes 24 times. So I have a greatest common factor of 6x in each term. So I'm going to pull 6x out of each term. If I pull 6x out of here, I pull the 6 out and I pull an x out, I'm left with x squared. If I pull 6x out of here, if I divide a 6 out of here, I'm left with negative 10. And I pull an x out, I'm left with 1 more x. And if I pull 6 out of here, 144 divided by 6 is 24. So I'm left with 24. And I pulled the x out, so no more x's. So now I have 6x times this. Now I can factor this. I have 6x, and this is 2 binomial factors. I hope. I might have to do quadratic on it. Let's see. This term goes here and here. The factors of this term go here and here. So I have to figure out the factors of 24 that would add up to be negative 10. So I know, let's see, 24 is 6 times 4. If they were both negative, let's see, negative and a negative make a positive, and a negative plus a negative make a negative. So that's going to work. Negative 6 minus 4. Check the inner terms. That would be negative 6x, and the outer term negative 4x, and they do add up to be negative 10x. And I've gone ahead and factored it. 6x times x minus 6 times x minus 4. This one asks what the zeros of this function are. You can go ahead to Desmos and graph this. Describe the end behavior and the turning points. Well, let's talk about this. If I multiplied this back out, I have 1, and I'm going to multiply and do all the binomials and then multiply this. I'm going to have an x cubed is what I'm going to have. So if I know I have an x cubed function and it's already factored, the zeros are where my graph touches the x-axis. It's where y is 0, okay? Where y is 0. Where does my graph touch the x-axis? That's what it wants to know, okay? What are those points? And I think this is positive, so it might do something like this actually, okay? Where are those points where it touches the x-axis? That's what it wants to know. Well, look, I know where it touches the x-axis. It's already in factored form. I set this equal to 0. It's going to touch the x-axis when this is 0, when x is 2, because if x were 2, 2 minus 2 is 0, it turns everything to 0, so at 2. And then if x here were negative 5, that's where the graph would hit 0. So what are the zeros of the function? 0, 2, and negative 5. So on my graph, I would hit at negative 5, so over here at negative 5, at 0 and 2. So let's see. My end behaviors, because I know my first term is positive, and I am positive, and I am odd. So if I'm odd positive, I start down and I end up. So I'm going to start down and end up. And so my graph might be something like this. Okay, something like this. Now I could go to Desmos and plug that in and see what it looks like. Let's try that. Okay, I went ahead and pulled up Desmos, and I typed this in, y equals x times x minus 2 times x plus 5, and it graphed this graph. I'm going to zoom out a bit so we can kind of look, and you can kind of see it's sketch of what I drew, but yes, it goes up, down, and up, and it hits at negative 5, 0, and 2. So there you go. This one says, what is a cubic function what is a cubic polynomial function in standard form with these zeros? If these are the zeros, I must have something like this, x plus 4, because if I plug in negative 4, this would be 0. X plus 5, because if I plug in negative 5, that would be 0. And then x minus 4, because if I plug in 4, that would be 0. Okay. This would be what my function would, if any of these were solutions, that would make this whole thing equal to 0. Okay. I want to set up a function, so I'm going to say f of x or y. And this is what my polynomial function would look like. Now, I could multiply this all out and actually find, you could give me this as a solution, or if it's multiple choice, you may have to multiply this out. So binomials, I'm going to go x times x and go x squared, x times 5, 5x. This is tedious. 4 times x is plus 4x. 4 times 5 is plus 20. Simplify the middle terms. You're going to have x squared. 5x and 4x is 9x plus 20. And then that was these two. Now you got to multiply by this times x minus 4. So go again. X times x squared is x cubed. X times 9x will be 9x squared. X times 20 will be 20x. Negative 4 times x squared is negative 4x squared. Negative 4 times 9, 9, 8, 30, negative 36. Negative 4, negative 36x, sorry. And then negative 4 times 20, let's see, 4 times 2 is 8. So that's going to be negative 80. Now I have to simplify all of this. I have 1 cubed, so it's going to be x cubed. I have 2x squared, so 9 minus 4 is going to give me positive 5x squared. I have 2 x's. Negative 36 minus 20 is going to be negative 16x minus 80 is what's left. And there you have your polynomial. Sorry, let's be accurate this, because it asked me for a function. I need to say y equals 2, or more accurately, f of x equals to this, because it asked me for the function. And that's where y would be 0 there, finding the zeros. Okay, what are the zeros of this function? Now with polynomials, you know you can take your last term and divide it by your first term and find all the factors of this divided by all the factors of this to figure out where your zeros are. But you don't even have to do that for this one. Look, they have a greatest common factor of x squared. Okay, so if I had to take all the factors of 3 divided by all the factors of 1 and check to see all the zeros, that's actually not so bad, because the factors of 3 are just 3 and 1, and the factors here are just 1. So you don't even have that many choices. But this factors out. X squared, x cubed, x to the 4th, they all have an x squared in common. Pull it out. That leaves you with an x squared, and here it leaves you with If I pull out an x squared, it leaves you with negative 4x. If I pull out x squared here, it leaves you with plus 3. Now I can just factor this binomial. Easy peasy. This is an x and an x. And the factors of 3, like I said, are just 3 and 1. Not many choices. This is negative, and that's positive. So if I make both of these negative, a negative times a negative makes a positive. And then this is negative 1x and negative 3x. It makes negative 4x. Bring this down. And I'm going to set that equal, f of x equal to 0. That's where y is 0. Now that will find me the zeros. That will tell me where my graph crosses the x-axis because y is 0. There's 2 x's here, so there's 2 zeros. So that's a multiplicity. So I'm going to have 0 multiplicity of 2. Okay, there's 2 of them. And then I'm going to have a 1 multiplicity of 1 and a 3 multiplicity of 1 also. So 0 multiplicity of 2, there's a 1 and a 3. Those are my zeros, and those are my multiplicities. Okay, this polynomial, it's a cubic, expresses the volume. Volume is in cubes, so this better be cubed, right? It expresses the volume in cubic inches of a shipping box, and the width, they tell you us the width, I'm going to circle that. The width is x plus 7 inches. If the width is actually 19 inches, what are the other 2 dimensions? Well, I can figure out the width, I can figure out x just from this. They told me the width is x plus 7. Then they said the width is 19, so 19 equals x plus 7. So I already know what x is. Subtract 7 from both sides, x is going to equal to 12. Okay, so I know x, but now I've got to figure out length and height, and so I can figure out all the dimensions. This gives us a hint. The height is greater than the depth. So let's write that over here. The height is greater than the depth, or I'm going to say length. Okay, height is greater than length, if you want to say length or the depth. Okay, because I like to do this. Volume is length times width times height. So they gave us the height and the width, and then they said depth instead of length, so I'm going to call length depth. All right, let's go ahead and figure this out. They gave us one of the factors. Now, I have a hard time factoring a cube. There's nothing in common here. How am I going to factor this? There are 4 terms I could factor by grouping. I could try that, but it's not going to work. So what I'm going to do is divide x plus 7 out of this polynomial and then have a reduced polynomial. Now I can do polynomial long division, but my choice is always synthetic division. I think it's faster. Okay, so it's x minus r here. So I'm going to put the opposite of this. If it's plus 7, I put a minus 7 here when I do synthetic division, because it's always x minus r. So it's the opposite of whatever that is. Then I take my terms, making sure to plot any zeros that I'm missing, but I'm not. So my constant here is 1. My constant here is 9. My constant here is negative 49. And my constant here is, oh, it's just a constant, negative 441. Okay, synthetic division, I bring this down and I do 1 times negative 7 and I get negative 7 and I add down because this is opposite, I'm adding down. I'm going to get 2. 2 times negative 7 is negative 14. Add down, let's see, negative 63. Negative 63 times negative 7, I'm going to do that on a calculator. It's going to give me a positive 441 and it should give me 0 here. If it doesn't, that wasn't a factor, right? X plus 7, but they told us it was, so it better be there, right? That better be 0. This is my depressed polynomial. It's 1 less in degree from that, so this is going to be 1x squared, and 1 less degree I start with, so then this will be plus 2x, and then minus 63. So if I multiply that by x plus 7, I should get back to my original polynomial. All right, I have an x plus 7. I know that was one of my solutions, okay, 7. Now I got to factor this to figure out my others. This, they told me already, was my width. Let's factor this to find my length and my height, or my depth. My depth and my height. So factor this, I'm going to have x and x. Let's see, the factors of 63 that add up to be 2. 63 is 9 times 7. Okay, so 9 and 7, and I want this negative and I want that positive. So I'm going to make the 7 negative and the 9 positive, because when I add this, the 9 is bigger than the 7, and that will give me a positive 2. So that will work, x plus 7 times this. So now I know this is my width. Now which one of these is my length or my depth, and which one's my height? Well, they told us the height is greater than the length, or the height is greater than the depth. So if the height is greater, x plus 9, if x is 12, x plus 9 is going to be bigger than x minus 7. So this one has to be the height, and this one will be your length or your depth, whatever you want to call it. Okay, so we figured that all out. Now let's find the other two dimensions. Well, if x is 12, then I plug in 12 here. The height will be 12 plus 9. And so your height will equal 21. And then the length will be 12 minus 7. So your length or your depth, whatever you want to call it, will be 5. 5 inches, 21 inches, and 19 inches. And you're done. All right, solve each equation. What are the real and or imaginary solutions for each polynomial equation? Now looking here, I have a cube. And one thing that you might do when you're solving a cube, let me just show you what happens when you do this. Let's say I want to get x by itself, so I subtract 343 from both sides. Now the hint here is, that's a 4 by the way. The hint here is I'm solving for real and imaginary solutions. So this is why this doesn't work. And I get 125 x cubed, and I have equals negative 343. Okay, negative 343. Now I'm going to divide both sides by 125, and I'm going to get x cubed equals, let's go 343 divided by 125, and it's going to be some negative 2.744. Now your next thing you might do is cube root both sides, right? Cube root both sides. So I can do that. X equals, you can cube root a negative number. You can't square root, but you can cube root a negative number. Now if I do this on my calculator and I cube root, I'm going to get negative 1.4. Okay, now here's the problem. You might say, well, why isn't that the solution? It is the real solution. This is the real solution to this equation, but I want my imaginary solutions too. So we have to actually solve a problem like this with cubes. This would be a sum or a difference of perfect cubes, okay? So when you're doing a sum or a difference, because I have a sum of perfect cubes, I'm going to write the sum of perfect cubes right here. If I have a sum of, well, I'm going to write a cubed plus b cubed. Okay, that would be the sum of perfect cubes. That's going to equal a plus b times a squared minus ab plus b squared. Okay, if I have the difference of perfect cubes, you make this a minus and you make that a plus. Okay, sum of perfect cubes looks like this. This is a perfect cube. It's 5x cubed. This is a perfect cube. It's 7 cubed. Okay, so test it. If you see a cube here and a cube here and there's only two terms, test and make sure it's not the sum or difference of perfect cubes. You cannot factor the difference, or you can factor the difference of perfect squares, not the sum though. Perfect cubes, you can factor the sum and the difference. If that's the difference of perfect cubes, that's a minus and that's a plus, but you need to know this. So instead, I do it like this. I use this little form, okay? I'm going to go a and b here, so this is going to be 5x plus 7 here. And then here goes 5x, that whole quantity squared, minus 5x, this is my a value, this is my b value, minus 5x times 7 plus my b squared, which is 7 squared. Okay, so this here is going to be 5x plus 7, and then this, multiply this out. If I square this, this will be 25x squared, and then multiply this out, negative 35x, and then 7 squared is 49. Okay, so now this has a solution. If I want to know where this, or sorry, let's write 0 on this side. This has to be 0 or this has to be 0. I can already see where this is 0. 5x plus 7, I can set it equal to 0, or I can say, if you want to come down and you can't see it, 5x plus 7, where is that 0? Subtract 7 from both sides. You'll have 5x equals negative 7, divide by 5. X equals to negative 7/5. Okay, so that right there, and that's what I already came up with. That's the real solution. 7 divided by 5 is 1.4, guys. I don't know why I said guys. Guys, this is negative 1.4, which is how I came up with it before already. That is the real solution right here. This part is going to be your imaginary solution. I can try to go ahead and factor this with two binomials. It's not going to work. So the solution here, if I put negative 7/5 in here, negative 7 over 5 times this gives me negative 7 plus 7, which is 0. So the solution here is going to be x equals to negative 7/5 for this real part. That's the part I came up with already. Now the imaginary part over here, the second part, I'm going to have to use quadratic formula here in order to solve this. So it's going to be a biggie. So we're going to go negative b, so negative 35, which makes positive 35, plus or minus the square root of b squared. So negative 35, I'm just going to write it out, negative 35 squared, minus 4 times my a value, which is 25, times my c value, which is 49, all over 2a. You got to know quadratic formula here. Okay, simplify this. What a big blob. Do all this, negative 35, square it, do all this, do the subtraction. I work this out, and this stuff in here becomes negative 3675. Now, when it's negative, you know it's an imaginary, and that's all over 50. Okay, now this guy, can I pull anything out of the root? Are there any big perfect squares that divide evenly into this? Well, 35, there is. 3675 actually breaks down into, let me see, 3675 divided by, it's huge. It's divisible by, it's divisible. If I break this down, this is 35 times 105, and 105 is 35 times 3. So it has 35 as a perfect square in there. So if I break this down, I can pull out a 35 and I'll leave a 3 inside. Now it's negative, so if I pull this out, this will be 35 plus or minus, because this is actually 3675 is 35 squared times 3. So when I square root the negative of that, this becomes 35 on the outside because I pull this out of the root, okay? And then I'm going to pull that I out, the negative 1, and make an I. And inside the root leaves me with root 3. That's all over 50. Now, I believe this is how the answer key leaves it. But here's my one real solution. Here's my two imaginary solutions. 35 plus 35i root 3 over 50 and 35 minus 35i root 3 over 50. It's ugly, but it's a real number. I mean, imaginary number, complex. So, but look, 5 divides into each of these. 5 goes into 35, it makes 7. 5 goes into 35, it makes 7i root 3. 5 goes into 50 and makes 10. So this is actually the most reduced. I think the book leaves it like this, but this is the most reduced. Right, guys? So your real solution, your complex solutions. You don't get this unless you factor the difference of perfect squares. If you just try to solve it the other way, you only get the real solution. Okay, let's use a little technique here. You've got a fourth here. I don't want to have to do that thing where I find all the factors of 44 and divide it by all the factors of 1 and then test them and see which ones work. I can see this is actually in quadratic form, except for that's a fourth. So here's what I do. I use u substitution. I just say, all right, pretend like u is equal to x squared. Okay, just say that for a second so we can factor this. If u is equal to x squared, that means u squared will equal x to the fourth. Okay, because if I square this, it becomes to the fourth if I square this. So x to the fourth would be u squared minus 40, and then u is x squared minus 40u plus 144 equals 0. So now this looks just like a quadratic. okay? In quadratics, I can factor like this, okay? So u goes here and here. And what are the factors of 144 that add up to be 40? Let's see. 144 that add up to be 40. 40, 12 and 12, that's not going to give you 40. Let's see, 36 and 4, that does give you 40. So how did I know that? I played around with it on my calculator a little bit. This is negative and that's positive. I want these both to be negative, so they add up to be negative. And a negative times a negative is a positive, so it works. Now I have u minus 36 and u minus 4. I don't really have u, what I really have is x squared. So I'm going to come back where the u is, and I'm going to place my x squareds there. So this was x squared, and this was x squared, okay? And so I have x squared minus 36 and x squared minus 4, and that's equal to 0. Okay, guys, my video stopped working, so I'm going to have to finish this problem. The number 16, I think we got to this point where we said x squared minus 4 and x squared minus 36 after we factored this. And then you can see this is the difference of two perfect squares again. So this can go, not again, but the first time, because we factored this trinomial to these two binomials. So we've got x minus 2 and then x plus 2 for this one. And then factoring this difference of perfect squares, it's x minus 6 and x plus 6. And of course, that's equal to 0. So using the zero product property, if this times this times this times this is 0, what makes these 0? So here it would be 2, here negative 2, here it would be 6, and here negative 6. So these are the solutions to this equation. Plus or minus 2, plus or minus 6. All right, let's look at 17. Number 17 is similar to 16. You have an x to the 4th here, so you can go ahead and use the u substitution if that works for you. So if you set u equal to the middle term, x squared, and you can see if I square this, I get an x to the 4th, so it works. And then u squared will equal x to the 4th. Then you can plug in, this would be u squared, and this would be u. So u squared minus 52u plus 576. Now that can be a perfect, let's see, not a perfect, this is a trinomial. It's equal to 0. Sorry, let's set that equal to 0. And we want to factor it into two binomials. Does 576 break down into something that adds to be negative 52? That's such a big number. That one's hard to figure out. You're going to have to just play with this. 576, what are the factors of it? Can they add up to be 52? You're going to have to play with this for a while. You can get out a calculator and try some different numbers and see if you can get something to add up to be 52. It actually turns out to be 16. I played with it for a minute. 16 times 36 does make 562. And 16 plus 36 does make 52. Now we wanted a negative 52. So we're going to go negative 16 times negative 36 makes a positive 576, and a negative plus a negative does make negative 52. So we're going to go here to u minus 16 and then u minus 36. These two multiply to make this. This middle term adds, and this middle term adds to make this. So that's set equal to 0. Now look what I have. I don't really have u, I really have x squared. So substitute your x squared back in. So where there's a u, I have an x squared in both these terms. And now what I have is u minus 16, or x squared minus 16, and then x squared minus 36. Once again, I have the difference of perfect squares here. So this does factor into x minus 4 times x plus 4, and this factors into x minus 6 times x plus 6, and you set that equal to 0. What makes these 0? Here you're going to have 4, here you're going to have negative 4, here you're going to have 6, and here you're going to have negative 6. So my values that work for this were going to be x equals to plus or minus 4, and then x equals to plus or minus 6. and there's your solutions. All right, on to number 18. All right, here we have x cubed minus 8 equals to 0. Now the problem with this is, if you'll notice back to the top of the problems, it said solve each equation, show the real and or imaginary solutions. Now if I were just to solve that problem by cube rooting both sides, I would only get the real solutions, but I want to know the imaginary solutions also. So I'm going to have to use the difference of perfect cubes on that one. Look at number 18. Let me just show you, if I were to solve this and just find the real solutions, let me show you what that would look like just so you see what I'm talking about. X cubed minus 8 equals to 0. Now I want to solve this, so I'm going to get the x isolated by itself by adding 8 to both sides. Okay. Then I would get x cubed equals to 8. Now I'm going to cube root both sides. Now when I cube root this, the cube and the cube root cancel each other out and I'm left with x. Now when you cube root, you don't do a plus or minus solution, because a negative times a negative times a negative is a negative, or a positive times a positive times a positive is a positive. So you know this had to be positive. The cube root of 8 is just 2, but here I only have one solution. I'm going to take cube root, so I should have 2 more solutions according to our rule. And that means I've got 2 imaginary solutions. I can't get it this way. How I have to get it is by using the difference of perfect cubes. So here, just like we did with this one, number 15 up here, that was the sum of perfect cubes. And anytime you see a cube like that, check that to see if that's a perfect cube. 8 is a perfect cube. It is 2 cubed. And I have the difference of perfect cubes. So you need to know the difference of perfect cubes factors like this. You have your first term minus your second term, because it's a difference. And then this is going to be your first term squared plus your first term times your second term plus your second term squared. Okay. Now if this was a sum, that would be a plus and that would be a minus. So this is x cubed minus 2 cubed. So I'm going to write it in its cubes so that I can factor it out like this. And when I factor it out, it's going to look like my first term will be x, and my last term is 2, x minus 2, and then my first term will be x squared, I square it, plus my first term times my second term, x times 2, or 2x, plus my second term squared, which is 2. So I'm going to put 2 squared here, which is 4. And this is positive, even though this is a minus, this right here is going to be positive, 2 squared. Now I set that equal to 0, because that's how it was set. Now I'm going to solve this. I can see the solution here is going to be 2, which I already did get when I just moved 8 to the side and cube root. This is going to be my imaginary part. I can go ahead and try and factor this, but there are no factors of 4 that add up to be 2. So what I'm going to have to do is quadratic formula. So let's do that. Negative b, so negative 2, plus or minus the square root of b squared. B squared will be 2 squared, which is 4. Minus 4 times a times c. Minus 4 times a, my a value here is 1. My c value here is 4. All over 2a. All over 2 times my a value here is 1. Now I'm going to simplify all this. 4 times 4 is 16 and it's negative. So this is going to be 4 minus 16, which is going to be negative 12. So I'm going to rewrite this as negative 2 plus or minus the square root of negative 12. 2 times 1 is 2. And then I know I had a negative in there because I had an imaginary solution. So that makes sense that is negative. Does 12 have any? Let's go ahead and pull this up here. 12 have perfect squares? It does. It's 4 times 3. And there's a negative 1 in there. I'm going to put that right here. Okay. 4 pulls out of the root and becomes 2. Negative 1 pulls out of the root and becomes I. So I can pull these 2 out, and what's left inside the root is 3. So this will be 2i root 3. So I'm going to go ahead and simplify this. This is going to look like this. Negative 2 plus or minus 2i root 3 over 2. Now, does this simplify any more? This derivative property allows me to divide into both terms, and if it divides evenly, it does simplify more. 2 goes into 2 one time, leaves me with negative 1. 2 goes into 2 one time, so this will leave me with plus or minus 1 times I, which is just I, root 3. This is still multiplied. So now this is my simplified version. So I have this as a solution, and here's my two imaginary solutions, negative 1 plus I root 3 and negative 1 minus I root 3. 3 solutions for a cube. Is this a factor of this? If it is, write p of x as the product of two factors. So to tell if this is a factor of this, just like if I were going to ask you, is 3 a factor of 12? Well, 3 would be a factor of 12 if 3 divides evenly into 12. Does 3 go into 12? Yeah, it goes 4 times. 4 times 3 is 12. And if I subtract and bring down, I have no remainder because it divides evenly, because 3 is a factor of 12. 3 times, and then I could write 12 as 3 times 4. Two factors, okay? That is the product of two factors. We're going to do the same thing here, but with polynomials. Is this a factor of this? Well, that means I'm going to divide this into this and see if it goes evenly. So let's go ahead and do that. X minus 2, evenly meaning with no remainders. Does this divide into x cubed plus 2x squared minus 6x minus 4 with no remainders? Well, let's see. Now, I could do synthetic division on this, but we'll do that for the next one. It would be quicker, in my opinion. But let's go ahead and do polynomial long division. So when I divide this into here, I want to know, I'm just going to worry about my first term, and that's my tag along. That's how I think of it. So how many times does x divide into my first term, x cubed? One more thing to remember, if I have a cube, I got to make sure everything's in descending order, and I have everything without a missing term in between. I have a cube, a square, a first power, and a constant. If I was missing one of these, I would have to put a 0 placeholder for it. Otherwise, things wouldn't fall in line nicely and things wouldn't add up nicely. So you got to remember that. X goes into x cubed. Well, x times x squared gives me x cubed. So when I write the term, I write it right here above my x squared term so that these line up. So I go x squared times x, and I get x cubed. And then I have to do my tag along. X squared times negative 2 gives me negative 2x squared. Now, just like when I do regular long division, I have to subtract and bring down. So subtract this whole thing. This becomes minus, this becomes plus. Distribute the negative. That eliminates. If that doesn't eliminate, you did something wrong. 2x squared plus 2x squared is 4x squared. Now bring down the next term, negative 6x. How many times does x go into 4x squared? Well, x times 4, first of all, and then I have another x here. So x times 4x gives me 4x squared. 4x times x is 4x squared. So go ahead and do it. 4x times x is 4x squared. And then do the tag along. 4x times negative 2 is negative 8x. Now these add up nicely. If you do it correctly, all your terms will add up nicely. Subtract and bring down. So I'm going to subtract this and add this, distribute the negative. That eliminates. Negative 6x plus 8x gives me 2x's. Now bring down the next term. So I'm going to bring down the negative 4, and I'm going to do it again. How many times does x go into 2x? It goes 2 times. So plus 2. 2 times x is 2x. 2 times negative 2 is negative 4, and look at that. I'm going to subtract and bring down, and everything lines up nicely. Subtract this, add this. They're going to eliminate and give me 0. So is this a factor of this? Yes, because it divided evenly with no remainder. Write it as the product of two factors? Okay. This is x minus 2 times x squared, and this is a positive 4x. I didn't write a plus. Plus 4x plus 2. And if I multiply this times this by going this times this, this times this, this times this, and then this times this, this times this, I'm going to get back to this. Now divide this by this. I can go ahead and do polynomial long division like I just did, or you can do synthetic division, which I think is much faster. Remember with synthetic division, you're always dividing by x minus r. So really what you have to think of is I have to take the opposite of whatever this is. If this is a positive, it needs to be a negative. If this is a negative, it needs to be a positive because it's x minus r. So this is x plus 4. So what I'm going to do with synthetic division is put a negative 4 here. Now I'm going to write all my coefficients here in descending order. So be careful here. I'm going to write negative 14. That's my first term. My next term should be a squared term, and I don't have one. So I have to write a 0 for my squared term. And I wrote a plus, but I just need to write a 0 for my squared term. It's not there. If you don't write that, this won't work. Then you have just an x term, an x to the first, and that would be my next term, so 14. And then my constant, negative 840. If you don't write this in the correct order, you're not going to get the correct solution, okay? So my x cubed term, my x squared term, my x term, and my constant. All right, with synthetic division, I bring down my first term. I multiply it by this, so I'm going to go, let's see, 4 times negative 14 is going to give me positive 56. Then I add down 56. 56 times negative 4 gives me negative 224. And I add down, and it's going to give me negative 210. Negative 210 times negative 4 is going to give me actually positive 840. So this is a factor of this. Add down, I get 0. So my depressed polynomial, I had a cube, so here I start with one term less. It will be a square. So this will be negative 14x squared plus 56x minus 210. And that is this divided by this. So if I take this and multiply it back by this, I should get back to that. Okay, this one asks us to use synthetic division to find p of negative 2. Now, what does that mean? P of negative 2 means if I plug in negative 2 wherever there's an x, what do I get out? Okay, I'm not asking you to divide by x minus 2. I'm not asking you to divide by x minus 2 or x plus 2. This actually would be x plus 2 because p of negative 2 would be an x plus 2. I'm just saying, what's p of negative 2? Well, I could plug this in here and find out, or I could do it a quicker way and just put negative 2 here. You don't change that sign because it's not x minus 2 or x plus 2. Just put negative 2 here and use synthetic division to figure it out. If I use synthetic division, my remainder I get will be the same solution as if I just plug in negative 2 here for each term. Same solution. So you could cheat and go ahead and plug in negative 2 here and not even do synthetic division. But I'd like you to use synthetic division so you can see this. So use your first term. Your first term, x to the fourth, would be 1. Your coefficient here is negative 6. Make sure everything's in descending order, 4, 3, 2. Then you would do a negative 2. Here's your x to the first term would be a 7, and your constant a 10. Everything's in order. There's no missing terms. You're good. Bring down the first term. 1 times negative 2 is negative 2. Add down negative 8. Negative 8 times negative 2 is positive 16. Add down, you get 14. 14 times negative 2 is negative 28. Add down, negative 21. Negative 21 times negative 2 is going to be positive 42. Add down, you're going to get 52. So this is not a divisor into this, so x plus 2 would not be a divisor into this. But when I want to find p of negative 2, I plug this into each term. I'm going to get out 52. And that's your solution. Okay, 22, find all the roots of the polynomial equation given that 5 is a root. Now they're nice to us here. Instead of saying find all the roots of this polynomial equation, it's a cube. It's not a perfect cube. I would have to figure out all my roots, I would have to take the roots of this and divide it by all the roots of the first term, and then go ahead and plug them in and see when I get to 0 to know if it's a root. But instead they said, oh look, 5's a root. So start there. If 5 is a root, that means I can divide that root out of here. So I'm going to divide 5 out. So if 5 is a root, that means I would have x minus 5 divided into this. So you could do polynomial long division, because if 5 is a root, that means 5 would work to make this 0. So x minus 5 would divide into this polynomial, or you could just take 5 and do synthetic division. So I'm going to go, synthetic division is quicker for me. So I'm going to go negative 1, and then my next term would be 5. My next term would be negative 11. My next term 55. Everything's in order. Check it. Descending order. Good. Go ahead and bring down the negative 1. Negative 1 times 5 is negative 5. Bring that down 0. 0 times 5 is 0. Bring this down negative 11. Negative 11 times 5 is negative 55. Bring it down, I get 0. It is a divisor. Sorry, they're all divisors. It is a factor, I should have said, instead of a divisor. It is a factor. So now I can go ahead and write the depressed polynomial, one less. So this will be negative x squared, and then 0 x's plus 0 x's minus 11. So I can really just write this as negative x squared minus 11, right? And that, if I multiply it by x minus 5, I'll get back to this. Now that I have this, I'm going to set it equal to 0. Well, I can't factor this. The roots of 11 would be 11 and 1, and then 11 and 1 don't make 0. So what I'm going to do is I'm going to go ahead and do quadratic formula. I'm going to go negative b, so I'm going to go, the b is 0. I'm going to go negative 0 plus or minus the square root of, actually before I do quadratic formula, I just thought of, I don't even have to do that. Let's just take this and solve it by adding 11 to this side, okay? This will work. Add 11 to this side. Instead of doing you could do quadratic formula. That would be fine, but this will be easier. That eliminates that. Bring down the negative x squared. Bring down the equals, and then you have 11 on this side. Now I can't square root both sides because I don't have x by itself, so divide by negative 1 first. You're going to get x squared equals negative 11. Now go ahead and square root both sides. Remember, when you square root both sides, you have to show the plus and minus solution. So plus and minus square root of negative 11 equals x. The square and the square root cancel, and you have x. Now this is almost solved. I know the square root of negative 1 is I, so I'm going to bring out the I. So I'm going to go plus or minus I square root of 11. And this is my other two solutions. Plus or minus I square root of 11 and 5. Those are the three roots for this cubic right here. Now, if I did quadratic formula on this, I would come up with the same solution. All right, find a third degree polynomial equation with rational coefficients, and it has these for roots, negative 4 and 2 plus I. Well, if it's a third degree polynomial, it needs 3 roots. So if negative 4 is one of the roots, 2 plus I is a root, I also know I have to have its conjugate 2 minus I as a root, okay? So I know that these are both roots. So I'm going to go ahead and go, all right, if they're roots, then I can go x minus negative 4 or x plus 4. If I set this equal to 0, then negative 4 is a root. So I know it's x plus 4. And then I'm going to go x minus 2 plus I. And then I go x minus 2 minus I. Now this is a lot of work here. Let me do a double parentheses here. I'm going to distribute this negative, and this would look like this: x minus 2 minus I, and x minus 2, and then that's going to make this a plus I. And then that all has to be multiplied by x plus 4. Okay. Now, this is going to look like 2 minus I is one term, but I'm going to treat them as separate terms. I'm going to have to multiply a trinomial times a trinomial, or 3 terms times 3 terms here. Let's go ahead and multiply this out, and then we'll come back and get this guy. So this is going to be x times x, which is x squared. X times negative 2 is negative 2x. X times I will be plus xi. Now do this center term. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I is negative 2i. Now do the third term. Negative I times x is negative xi. Negative I times negative 2 will be positive 2i. Negative I times positive I, let's write that up here. Negative I times I is going to be negative I squared, which is negative 1 times I squared. Well, I squared is negative 1, so it's a negative 1, which makes it a 1. So negative I times I is going to be plus 1. Negative I squared, negative 1, which is 1. Remember, I squared equals negative 1. If you've forgotten that, I squared is negative 1. Okay. So now I have all this, and I still have to multiply all of that by x plus 4. Oh my gosh, it's a lot of work, but let's go ahead and simplify it a little bit here. The x squared term, is there any other x squared terms here? No. Bring that down. I'm going to just bring down the x squared terms. Negative x, are there any other, or excuse me, negative 2x. There's another x here. Okay, so those are the only x's. Negative 2x and negative 2x makes negative 4x. So I got that term, I got these terms. And then let's see here. We have xi and negative xi. So those just actually cancel each other out. They're gone. I have negative 2i and positive 2i. Once again, those cancel each other out and they're gone. And then I have 4 and 1, which makes 5. So all of that multiplied out, this times this, gives me x squared minus 4x plus 5. Now, if I would go ahead, and the reason that these are solutions is because this gives you imaginary solutions only. There are no terms of 5 that add up to be negative 4. All right. And then I'm going to multiply that by x plus 4. Now I go ahead and distribute this. This times this gives me x cubed. This times this gives me negative 4x squared. This times this gives me 5x. Now do the second term. 4 times x squared will be 4x squared. 4 times negative 4x will be negative 4x squared. Excuse me, I lied. 4 times negative 4x will give me negative 16x. I can do it. And then 4 times 5 will give me plus 20. Okay, simplify this. I have 1x cubed. I'm going to bring it down here. I have an x cubed. That's gone. Other x squareds, I have a negative 4x squared and a positive 4x squared, so those actually go away. I have a 5x and a 16x. That's going to give me negative 11x. And then I have plus 20. And this will be my trinomial, my third degree polynomial with rational coefficients with these roots would be x cubed minus 11x plus 20. Okay, use Pascal's triangle or the binomial theorem to expand the binomial. I choose to use Pascal's triangle. The binomial theorem has terms that basically mean the same thing. They're a little confusing to look at though. Pascal's triangle starts out with the 0 term. Anything to the 0 power is 1. And then your coefficients for the first term, so a plus b to the first. This would be a plus b to the 0 power. Anything to the 0 is 1, a plus b to the first power. Then you do 1 and you add these together, you get 2 and then 1. Add these together, you start with 1, 3, add these 3 and then 1. We need to the 5th. So this is the first, this is the second. This would be the 3rd, 4th, 5th. So let's expand all the way to the 5th. So we'll go 1, these give me 4, these give me 6, these give me 4, this gives me 1. So that would be the 4th row. Now we need the 5th row. 1, these give me 5, these give me 10. This gives me 10. This gives me 5, and then the 1 on the outside. So here's my 5th row. It's hard to see because I'm messy. 1, 5, 10, 10, 5, 1. These are the coefficients of the terms when I expand this out. Otherwise, I'd have to write 2v plus s times 2v plus s times 2v plus s 5 times and do all that multiplication. Oh my gosh, that would take forever. Now remember, these are my coefficients. Now the exponents look like this. If I have a, just to remind you, if I have a plus b to the 5th, it looks like this. You take your first term to the 5th power, and your second term will be to the 0 power. Anything to the 0 power is just 1, so I don't write it. Then next, you would go a to the 5th, b to the 4th. Excuse me, I lied. B to the 1st. I lied again. Let's try that again. You would go a to the 4th, you depress this one, and b to the 1st. So these add together to be 5. Then you take that down 1, you go a cubed, b squared, take that up 1. These still add up to be 5. Take that down 1, that up 1. A squared, b cubed. These still add up to be 5. Down 1, up 1. A to the 1st, b to the 4th. These still add up to be 5, and I wrote a plus. I am sorry. I meant b to the 4th. These are multiplied. Then my next term would be a would go to the 0 power, which is 1, and b to the 5th. So each of these decrease by 1, okay? And then each of these increase by 1. And that's how you write your polynomial. So let's go ahead and write this out when we expand this. We got our coefficients. Let's expand it all out. And we're going to start with our coefficient of 1. We take our first term, it's 2v. We're going to take that to, we start out with the 5th power, and we start that out with s to the 0 power. So I'm not even going to write it. Okay. Then I take my next coefficient of 5. I take my first term and I'm going to depress it by 1. This is to the 4th power. Then I take my second term and it is to the 1st power. Then I'm going to go next will be 10. And I take my first term and I'm going to depress it by 1. 2v to the 3rd power, and then s will be to the 2nd power. Then I take my next coefficient, which is 10. Take my first term and I'm going to depress it by 1, 2v squared, and this goes up by 1, s to the 3rd. Then I take my next coefficient, which is 5, not to be confused with s. And I take my first term, 2v, and I depress it by 1, so it's going to be to the 1st power, which I don't need to write, and that goes up by 1, s to the 4th. Then I take my last coefficient, which is 1, and I go 2v to the 0, which is just 1, so I don't write it, and then s to the 5th power, s to the 5th power. Okay, there I have it. Now just simplify it. I have to distribute this 5 because this is 2v cubed, so I have to cube the 2 and the v. So if I cube 2, I'm going to get 32, and that's just 1, so 1 multiplied by 32 is just 32, v to the 5th. Plus, distribute that. If I take 2 to the 4th power, well, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I have to go 16 times 5, which is 80, v to the 4th times s. Then simplify this. I have to cube this. 2 cubed is 8. 8 times 10 is 80. Once again, 80. Then cube the v. V cubed, s squared. Do this one. 2 squared is 4. 4 times 10 is 40. V squared, s cubed. Then do this one. 2 times, this is to the 1st power, so that's just going to be 2 times 5, which is 10. V, s to the 4th. And then 5 times, or excuse me, this is s to the 5th times 1, so plus s to the 5th. So check your coefficients. You went v, it was to the 5th, to the 4th, to the 3rd, to the squared, to the 1st, to the nothing, and then check your s's. S to the nothing, s to the 1st, s to the 2nd, 3rd, 4th, 5th. You've done it correctly. Those are your coefficients. This is it expanded out. I looked at the answer key and they started here. They went this term, this term, this term, this term, this term, this term, which is counterintuitive to how you would multiply this out given that. But basically they wrote it like this just for ease. They wrote s plus 2v and expanded it out that way. They flipped these around, but it's the same. So, all right, that's how you do 24. Let's do 25. All right, 25 asks for only the real zeros, so I don't have to worry about factoring. I just want real zeros, so that means I can just solve this. If we want the zeros, we basically are looking for where y is 0. Where is the graph going to touch the x-axis, right? Where it touches the x-axis, it does that when y is 0. So I set this equal to 0. 0 equals to x minus 12 cubed minus 10. And just solve. Add 10 to both sides. You're going to get 10 equals x minus 12 cubed. Now because I only want real zeros, I can go ahead and cube root this. So I'm going to cube root this on both sides. Now cube roots, I don't have to show a plus or minus solution because cube roots can be negative. All right, so I cube root this side and I get x minus 12. And I cube root this side. Unfortunately, 10 is not a perfect cube, so I'm going to leave it under the cube root of 10. So the cube root of 10 equals x minus 12. Still solving for x. I'm going to get rid of the 12 by adding it to both sides. And I'm going to get, that eliminates x, and then on this side I have the cube root of 10 plus 12 on the outside. 12 is not under that root. And that would be your solution. And that's all you have to do here. Oh, it has us pick A, B, C, D in this one. So in this, the cube root of 12, or excuse me, the cube root of 10 plus 12, it would be D. All right, guys, that's how you do this practice benchmark. Let me know if you have any questions and have a great day.